Triple kill. Multi-kill. Mega kill. Ultra kill.
Oh, hey, I didn't notice you there. I was just playing games on my gaming PC inside my gaming arcade. Let's talk about it.
I've made a number of Raspberry Pi arcade cabinets, and it's come time to give the PC gaming world some respect and build a PC-based cabinet. Originally, I wanted to theme this cabinet for classic Doom. It was the game that got me into PC gaming back in the Pentium 486 days. That early to mid-90s era of first-person shooters has some of my favorite memories, most being on the Build engine. I played around with some artwork concepts for this Doom cabinet, but I just wasn't satisfied with the direction I was headed. A Doom-themed cabinet just didn't have enough personality to represent PC gaming. So I pivoted to the game that I played the most during my early PC gaming days, and that's Duke Nukem 3D. I decided to switch to this theme, but unfortunately that art direction also sort of staggered out, and I really didn't know what to design other than just slap the cover art of the mostly used Duke Nukem 3D poster. I think the real issue was there wasn't anything new or unique about this cabinet design. It was an arcade and it was less PC gaming. So I decided to step back and do some research. What is PC gaming? What makes PC gaming recognizable? Regrettably, I turned to the internet for inspiration. What is PC gaming?
What is PC gaming?
For you are weak, and I am mighty!
Oh. Yeah, that's PC gaming.
PC gaming is about RGB lights, specs, and showing off. Unfortunately, I don't have a budget near that, but we're gonna try.
Well, taking everything we've learned, I'm going to try and embody the PC Master Race aesthetic as best I can, but with extreme prejudice to cost because, well, no one watches this YouTube channel, and whatever I spend, I'm never going to get this money back anyway. So, the goals for this build are ultra small form factor. I have a small arcade cabinet to work with, so that PC has to fit inside. It's got to be quiet since we'll be playing next to it. We need extreme performance to be in the PC Master Race category. Got to have mechanical keyboard with backlit keys, and we need case windows or viewports to see what we're working with. A single power supply, so all the arcade individual components also have to be powered off the main PC supply. RGB lights, and we might as well just future-proof ourselves and go for 120 frames per second. Add some unnecessary accessories, and stay within our budget of $70. I think we're set up for success. So let's get building. First on our list of stuff to buy is the computer. Not just any computer, but a form factor that will fit inside my tiny arcade cabinet. Let's see what's on the market that fits within our budget. And remember, that's low. Unsurprisingly, nothing. I want a Windows PC to represent PC gaming, and all noteworthy form factor options are around the $300 to $500 range, and I don't want to use a Raspberry Pi. So instead, let's turn to legacy hardware, which is always a you get what you pay for type of gamble. Most of the time it doesn't work out. But with the magic of editing, I found a solution. I can say there is a PC line that intrigues me the most, and that's the thin client line of PCs. For $30, and that's what I paid, I'll explain the benefits and the butthurt of this server-based PC variant. Thin clients are cloud-based computers. They're more cost-effective to deploy in a business setting where the end user just needs a workstation for low-resource data entry, like running a virtual desktop, or web-based work. The heavy lifting is done on a remote server, so these units generally have all the I/O to interface to modern peripherals while lacking in the performance area. And we're on a budget, so we have to take that. These thin clients usually typically run on a form of Windows embedded, and the drivers for them are a huge gamble without access to that software. Finding a model that can support a full Windows install is hit or miss, but this Z90SW unit can handle it. Spec-wise, there's nothing special. It's a AMD GT52R at 1.5 GHz with DDR3 RAM, and this unit came with a 4 GB flash hard drive. But what is really special is actually those last two things I mentioned. So let's upgrade to our PC Master Race on a budget. The RAM is full size, so we can upgrade this with some DDR3 RAM with the obnoxiously large heat sinks, and that's going to be two 4 GB modules. The hard drive motherboard connector is SATA, so we should be able to fit a larger module and add more storage. A full Windows 7 install will not fit on that stock 4 GB flash drive, so we need at least 20. And just to be clear, with our budget, most M.2 hard drives are out of the question, but it's not really a big loss, as every M.2 drive I looked at will not fit inside the motherboard layout. There's just too many components in front of that SATA connectors for this thing to fit. So what can we do with about $20 in the hard drive category? Well, a refurbished 60 gig solid state drive. And doesn't fit, you say? Well, add another $4.50 to this, and that SATA extension cable will do the job just nicely. 60 gigabytes not enough storage, need a redundant RAID array. This $8 USB 3.0 hub, along with some promotional USB flash drives, will bump up our storage to about double that, and this is going to be 4 16 gigabyte USB drives. So I think we've got a beast of a machine worthy of a Rate My Setup, but first, to manage our expectations, let's check the Windows Performance Index. Excellent. It's good to be modest. Powering this unit is where the butt hurt really starts. The official Dell power supplies for this unit are about $30 each. It's the same price of the PC on this aftermarket. And unfortunately, a power supply didn't come with this unit when I bought it. I do not want an off-brand power supply because I'm going to power the entire cabinet with this single supply, so a quality power supply is priority. Our budget doesn't permit buying an official Dell supply at the $30 price point, so what can we do? Fortunately, I always grab Dell branded power supplies whenever I see them at the thrift store, and I have a couple here. Unfortunately, now we have to play the proprietary barrel jack lottery. Of course, these power supplies match in voltage and current to power our thin client, but the barrel jack is nowhere close to the correct size. But would you have guessed there is a barrel jack adapter for this exact scenario? I didn't either, but there is. This convenience is not cheap, but it's cheaper than buying the official Dell Wise thin client power supply. This power supply outputs 19 volts, and most of our arcade electronics need 12 or 5 volts. I modified my arcade power block to break out two of these switching buck converters. This way we can maintain using a single power supply brick for the entire arcade. Matching all these components, adapters, extension cables to Frankenstein this PC together took a significant amount of time. I did verify this unit can handle a full Windows 7 install and spent the better part of a day tracking down drivers to support the integrated graphics and chipset. Here's the unit on a life support power setup. All I'm doing here is just making sure we can get to the point of a game running on this PC before I actually design a cabinet around it. When it's all said and done, this was quite the chore. That's it for the raw horsepower running inside this cabinet, so let's move on to the body. Next we'll look at the case and the unnecessary parts that make up this arcade a PC Master Race worthy contender. This cabinet design derives from the American Neo Geo MVS cabinet. The rear sloping body and cut corner at the bottom are inspired from the Neo Geo MVS, and this is a miniature interpretation of it. This is one of my larger mini arcade cabinet designs, but it just wasn't large enough to fit this thin client PC inside. The original cabinet needed some redesign and to add room for a larger PC footprint. I'm already in too deep to buy a different PC, so I'm going to make this fit. Modifying one of my existing cabinet designs is more within my field than buying another underpowered PC just so it fits. I squared off the rear to add an extra inch to the internal cabinet depth, which was just enough to fit the thin client. However, this little variation between the two cabinet designs wasn't much to warrant a new video to talk about I put a PC inside a cabinet. After all, putting a PC inside an arcade cabinet has been done before, so I sat on this project for a while waiting for the right idea to come. Looking for inspiration, I again turned to what is popular for PC case designs. Cases have one thing in common: clear window cutouts. This is the showing what's under the hood feature, and that's where I started. There was a lot of back and forth trying out designs and drafting versions that fit the original cabinet features. Something that looks right is difficult to do in CAD without seeing the finished product. The struggle here is trying to balance lines and aesthetics of the cabinet with the extremeness of the PC Master Race aesthetic. This is just a big guess as far as direction of how I want it to look. However, adding colors and as much detail as possible into the CAD model helps sell the final design and a commitment to it. Adding some extra flair as far as porthole covers or bullseye window borders was only done because I had some acrylic stock that I was sitting on. I was worried that all these cutouts would weaken the overall structure of the cabinet. I did a simulation in SOLIDWORKS to determine if there's enough strength where the control panel rests. This is where most of the force is seen when in use. I'm using 45 newtons normal to the plane of the control panel. This is about 10 pounds of force. I'm pretty sure I did this simulation wrong. Using the weakest material for wood, or balsa in this case, I can't say I recall wood being so elastic. I don't know much about what the actual elasticity values are wood for, but I'm willing to risk it just to move forward on with this build. After cutting the cabinet and doing some photo drafting, that's really just where I take a photograph with a ruler for scale and trace over that photo in CAD. This helps with the alignment of I/O ports and access panels instead of the guess and check method. This completes the actual arcade. The assembly of the cabinet is nothing new to my previous arcade. I'm going to skip most of that assembly and move on to finishing and paint. I went with the popular matte black paint theme, and that's because I want to focus on some special features like a custom joystick fit for PC gaming and some other unnecessary accessories that puts the Y in DIY. I'll start with the control panel. Back when I was brainstorming this arcade and stuck on the general theme, I wanted to do something different than a traditional control panel. A traditional joystick and button layout wasn't hardcore enough for PC gaming. I had an idea to make a WAS key layout into the cabinet control panel. The first attempt was with the standard 28mm buttons, which were too big. The second attempt was with smaller 24mm buttons, and it was still too big. The problem with emulating a button layout to feel like a keyboard is it will never feel like a keyboard unless it's a keyboard. So I made a keyboard. Well, more of a 10-button keypad. Instead of row column indexing, I made each button a discrete input since this is more applicable for arcade building. I also used the same pinout for the directional buttons to match with standard arcade joysticks. This means it's a direct connect to most keyboard encoders as the headers have the same pinout as an arcade joystick. That means the pins are mapped up, down, left, right, ground from the top view. This PCB fits standard Cherry MX switches with the option for a 3mm backlight LED. You can find this PCB linked in the description below if you're interested in it. I didn't realize how expensive custom keycaps are, so I've opted to buy 2 generic 9-button packs to complete this 10-key layout. Don't mind the 2 escape keys. This keypad turned out pretty well, but it took some time to get some adjustments and get the feel right. Your hands rest on this keypad differently than a joystick, so positioning it further up on the control panel was necessary. I also didn't realize what R1, R2, R3, R4 means in the world of keycaps. This really just means the heights are different. You can't just put a F1 key next to the letter C key because they change heights the further you go into the keyboard. Overall, I'm happy with the results. I had plans to incorporate some silly status readouts for this computer arcade. Remember widgets? Well, before those, we PC users from the 90s and 2000s had real panel mount 5¼ drive bays full of useless dials, gauges, and fan controllers. I really wanted something like this, but with all the cutouts I made in the arcade, there wasn't much room to add something this size. I considered a dual readout in the middle of the arcade, but this looks silly in CAD, so I scaled down and stuffed the LCD into the control panel. An Arduino drives this 2x16 LCD along with 2 TMP36 analog temperature sensors and a DHT22 for the internal cabinet humidity and air temp readout. Here's a mock-up of reading the CPU and RAM temps on this piece of aluminum, since I couldn't really fit the camera inside the arcade to do this. I wrote some code to animate a bar graph equivalent to the temperature fluctuation. The screen was too small to show all the data I wanted, so the display cycles between 2 screens of information instead. My original plan was to display too much information in the spirit of useless PC hardware for your drive bays. However, space was very limited, so this will just have to do. I'm sort of fixated on audio spectrum visualizers. In the days of analog home theater setups, this was the pinnacle of cool in the 80s and 90s. I wanted to add one of these modules to the arcade, so I bought a bunch of different visualizer modules, hoping I could fit one into the Marquee. I couldn't. I selected the best module that would fit and painstakingly drew cutouts so I could integrate it below the speakers. I'm sure it bothered a few people earlier, so we have to circle back and fix something. This hard drive and RAID array can't sit all loosey-goosey, so I did make a 3D printed bracket to make the install have some intent. Now we can move on. Now we can't forget the most important part, RGB lighting. What's the point of all the windows without some color? Another Arduino Uno drives 160 NeoPixel LEDs. In retrospect, one of these DPS 5015 power supply modules would have ticked 2 boxes, that's power regulation for the LEDs and being a neat display readout, but again, budget, time, and space got in the way. There's quite a bit of variation in current draw as the NeoPixels change, so one of these DPS 5015 power supplies would be a nice upgrade for version 2. I've been glossing over the Marquee because I've already mentioned the audio visualizer plan didn't work out, but there's still hope. My PC game collection is primarily CDs and DVDs, and this thin client has no optical drive. What to do? I admit this solution looks half-assed, and that's because it is. I originally had plans to put a full 5 1/4 optical drive in the cabinet, but that was before I had all these clear window cutouts, and now have no space to hide one of these enormous drives. Instead, I already have this portable DVD drive, so I'll just make a shelf for it and stuff it here. I'm going to call this done. As far as a mouse for PC gaming, here's a discarded Dell optical mouse. Nothing like the 3-button standard. If you want something with more flair, this is the Nunchucky. It's a breakout adapter that works in conjunction with the Adafruit Pro Trinket to turn a Wii Nunchuck controller into a USB mouse. It's pretty okay. Let's see, did I forget anything? There's some internal storage for the mouse and a gamepad, and that's just a quality of life thing for this arcade. There would be a lot more storage without all the extras we've added, but we need these things because we're trying to look important. Oh yeah, I've added fans and a button for the fans. They're extremely loud, but it's part of the PC territory. Okay, so let's check the budget and see how we did.
It was gonna happen. I mean, our original goal was $70 for the PC, and we got pretty close if you consider just the base stuff. Yeah, of course we're gonna go over budget. But if it performs well, then maybe it's worth it.
So I ran some PC benchmark software to really get a gauge of where we are with our PC Master Race system, and the results are below average. So compared to modern day builds, this is a bottom tier PC, and that's fine because, well, for modern day builds, this is a budget machine and corners will be cut. Overall, this PC is within its expected category, but it's a very slow single core processor, graphics are non-existent, solid state drive is slow. We do have enough memory to run any version of Windows, and though it goes back, writes, and insults me, Windows 7 is 10 years old now. That's fine. Here's what's under the hood. It's a slow single-core AMD. The integrated graphics are pretty much non-existent. The solid-state drive is slow. I don't know what's going on with my RAM because it's covered in heat sinks. It should be better than this. Can't run any of these games, but is it really terrible? Well, the price isn't terrible considering I paid $2 more than what it estimates. So that's the good news, but let's be the judge and run some actual games on this machine and really analyze its true performance. Here's our first PC benchmark, Dino Crisis 2. This PC port is frame capped, and there's not much going on as far as 3D rendering. I also didn't map any of the controls at this point. There's not much going on, but it's very playable. Next is Thief the Dark Project, which also worked from a vanilla install. Unfortunately, we're also capped at 60 frames per second, but for this game, which is pretty slow paced, this is great performance. Half-Life, which is everyone's benchmark. This game is very playable, but unfortunately we're only getting average 30 frames per second. We peak at 60 when nothing's going on, but I expect in outdoor sceneries this performance to get worse. Need for Speed 2, which is a more modern release, does get upper 40 frames per second and is very playable. The GZ Doom port has excellent performance, 100 frames per second or more. Sin, which is a heavily underrated game and was overshadowed by Half-Life, has excellent performance after it's been heavily patched. This was very difficult to get running, but I wanted to show it off. Sonic Robo Blast 2 is a game based off a heavily modified Doom engine, and it's very fun. It is capped at 35 frames per second. Unsurprisingly, Doom 3 runs extremely bad with like 10 frames per second. Here's a look at the internal temperatures of our CPU and RAM under heavy load.
Mars City is a smoke-free facility. Please smoke only in designated areas. Thank you for your cooperation.
This is the Megaton edition of Duke Nukem 3D, which has extremely good performance, easily 100 to 150 frames per second, depending on the action.
So, how'd we do? So overall, I think we did really well. There were some issues with this arcade that I didn't care for. For example, in order to do the RGB lighting, the entire inside of the arcade had to be painted black, and it had to be painted pretty well. So this was tedious, time-consuming. I don't particularly like painting, and having to paint essentially double the arcade in a hard-to-reach place, I hated doing this. Just installing PC games took the better part of an entire day, especially because most of these games that I have that I like playing are for older operating systems from Windows 95 to Windows XP. Basically nothing native to Windows 7 except some of the modern build engine and Doom ports. So this was not fun getting these to run, but it is nice to get them to run on such a modest machine, but I would never do this again. I was actually surprised that we got 120 frames per second. I initially made that goal before doing any of the game testing, and I expected to fail there, but I didn't. I did expect to fail in the budget. The best feature about this CAD is the case windows. But it's also the worst part because I can't hide any wiring where I route cables, hide power supply modules for the cabinet, and it is actually its downfall. So on a close inspection, you can see like I didn't tape down the NeoPixel lights because I might use them for something else later. I didn't really do a good job of routing cables because I normally hide all that stuff inside a cabinet body. From 20 feet away, this arcade looks pretty cool. You can't see all the wires, but they're there. And finally, I actually started this project back in March of this year, but it took such a long time because I had some unexpected projects that came about, and I'll just disclose that one now because it's out, and that is I co-authored a book on how I design and build arcade cabinets. So you can find it wherever books are sold, Amazon, Barnes & Noble. It's in digital and paperback format, but I ended up getting approached to co-author and complete this book in a really tight time frame, which was over the summer. So basically I had to drop everything, do my full-time job, and put this on hold until I finished that book. So that was a massive amount of effort that pretty much delayed everything by 6 months. So I'm back on track with stuff, doing YouTube and doing the arcade side project stuff. So thanks for your patience. There is a link of where you can get that book. If you like what I do, that book goes into extreme depth of fundamentals of planning all the way through to execution to the final product, which something like you can see here. And you can bet the models that I made for this book, I'm actually going to get a lot of mileage from them now, because I plan to do a lot of tutorials on how to CAD, how to get started designing in 3D, all based on arcade projects or video gaming related projects. So thanks for watching, everyone. This project took forever. This video took even longer, but if you got to the end, I appreciate it. Take care.